Welcome, Matt, to the last video of the year. This is Quadratic Formula Day. This is the last one we're doing. This is for the week of May 18th to the 22nd. It is your very last one. Congratulations, you have made it to the end. You might be thinking, oh my gosh, why so much work at the end? Remember, we're not doing finals this year, so I got to give you a little bit of something to work on, right? I want you to have a great, great summer. Please come by and see me, say hello. Love to see your smiling faces. I look forward to seeing how you guys do in Math 3 the next year, all that kind of good stuff. But excited because this is it. This is the last one. So without further ado, let's get it over with. Ready? All right. Quadratic Formula Day. So it says, when you encounter a quadratic equation that is difficult to factor, you can use the quadratic formula to determine the roots or the zeros. For a quadratic equation of the form ax squared plus bx plus c equals 0, the solution or roots can be calculated using the formula. And here's the thing is, you can use the quadratic formula for any quadratic equation, okay, at any time. You doing it, it's actually sometimes easier than it is factoring. It's a lot of work, whatnot, but if you can struggle with factoring, you could always use the quadratic formula. And that formula is this. It is negative b plus or minus the square root of b squared minus 4ac all over 2a, okay? Now that b squared minus 4ac is inside the parentheses, and we're going to call that the discriminant, okay? And more on that here in a little bit, okay? But this is your quadratic formula. This would have been one of your extra credit kind of projects to help you out at the end of the year, making a couple posters and all that kind of stuff. But obviously we didn't have that opportunity this year. So let's do it. Before using a quadratic formula, be sure to write the quadratic function in standard form, and that is ax squared plus bx plus c, right? Standard form of a quadratic trinomial. So example 1, negative 4x squared minus 4x minus 99. I want you to first determine what is the a, the b, and the c term. So when I look at this, my a term is going to be negative 4. My b term is negative 40. My c term is negative 99, right? Negative 4, negative 40, and negative 99. Now, next, substitute the values into the quadratic formula. Hey, big reminder right here. Be sure to use parentheses when substituting so you can keep track of the correct positive and negative signs. What I mean by this is this. I know the formula is negative b, and so I know my b term in this case is negative 40. So I know that x is going to be equal to a negative because it's negative b. And my b term is a negative, so I'm putting inside parentheses. Plus or minus, right? Because remember, anytime we do a square root, it's technically plus or minus. The square root of b squared, negative 40 squared minus 4 times a, negative 4 times c, negative 99. And that's all going to be over, and that's all of it is over 2 times my a term, which is negative 4. Now, let's simplify this to determine the zeros of the function, okay? So I know a negative and a negative become a positive, so x equals 40 plus or minus the square root. And negative 40 squared. So negative 40 times negative 40 is a positive 1600. Negative 4, and you're going to need your calculators today, so I've got mine right here. Negative 4 times, because it's minus 4, right? Times negative 4 times negative 99. I get negative 1,584. because 3 negatives make a positive or make a negative, right? Negative or minus 4 times negative 4 times negative 99. There are 3 negatives there, so it's going to be negative. And that is all over 2 times negative 4 or negative 8. So now I have x equals 40 plus or minus. Now 1600 minus 1584. I'm going to do that without being in a radical for right now. And that is 16. 1600 minus 1584 is 16. So I'm going to take and write the square root of 16 all over negative 8. Now, we all know what the square root of 16 is. What is it? Yeah, it's 4. So we're going to have 40 plus or minus 4 all over negative 8. Now, how many solutions do you think we have to have? Well, if you just said in your head 2, you are right. Because remember, this is a quadratic, so there has to be 2 solutions, right? There has to be 2 solutions. Now, there could be a double solution, right? It could be the same at the end of the day. It could end up being the same. It could be a double solution, but we won't know that until later on. But always go in the mindset that there's going to be 2 solutions, okay? So, as I do this, I'm going to do the first one in red. And what I mean by that is I'm going to take the positive 4. So I'm going to say 40 plus 4 divided by negative 8, which is 40. 40 plus 4 is 44 divided by negative 8. So 44 divided by negative 8 is going to be negative 5.5. And I'm going to use a decimal for that. Okay? So I know that one of my solutions is x equals negative 5.5. And that's one of them. Now, let's do the other one in green. X equals 40 minus 4 over negative 8. So x equals 36 over negative 8. And x equals negative 4.5. So my 2 solutions here are negative 5.5 and negative 4.5. Those are my 2 solutions, this one and this one. Okay, let's do some more. Okay, the best way to do the quadratic formula is simply do them. All right, so let's look at the first one. G of x equals 3x squared plus 2x minus 4. So when I see this, I know that my A term is 3, my B is 2, and my C is negative 4, right? So I'm going to go ahead and start plugging it in. X equals my negative B, so negative 2 plus or minus the square root of 2 squared minus 4 times A, which is 3, times negative 4. So this becomes, and all over 2 times A. So 2 times 3. I'm worried about how small I'm writing so you guys can see it or not, right? So I'm going to try to write a little bit bigger right over here. I'll box this in so I can write. So x equals a negative 2 plus or minus the square root of 2 squared is 4. Now, I'm going to use my calculator for the other part, and that is negative 4 times 3 times negative 4, and that equals 48. So 4 plus 48, okay, all over 6. So here we go. X equals negative 2 plus or minus the square root of 52 all over 6, right? So now let's look at the directions real quick to make sure. Use the quadratic formula to determine the roots for each term. At this time, if necessary, give your solutions as exact answers in simplest radical form. We want no decimals this time. So I got to simplify radical here. All right, and remember, I'm looking for two. One with the positive square root of 52, one with the negative of square root of 52. So let's do the positive first. So I have x equals -2 plus the square root of 52. Well, the square root of 52 breaks down into the square root of 4 times the square root of 13, and that's all over 6. So this is x equals -2 plus 2 square root of 13 all over 6. Now, since there is a 2 in front of the radical and a 6, and they all have a greatest common factor of 2 between them, I can actually reduce this down and say this is a -1 plus 1 square root of 13 all over 3. So this is one of my solutions right there. -1 plus the square root of 13 over 3. That is one of them, okay? Now, let's look at the other one, and I'll do it in a different color. So the other one is going to be the x equals the -2 minus the square root of 4 times the square root of 13. And I'm literally just picking up right next to it, right? Because I already know that the square root of 52 breaks down into 4 times 13, right? So, and that's all over 6. So this becomes x equals -2 minus 2 square root of 13 all over 6. And that can be reduced down to -1. Come on. -1 minus the square root of 13 over 3. And this is my other solution right there. Okay, so those are my two solutions. None of this is really difficult. It's just long. Okay, it's just long, and you got to stay accurate. Okay, let's erase here a little bit, give ourselves some room. Hopefully you've got all this down, and I'm going to go ahead and erase all this. And so we're going to have some room. Okay, so if you need this still, just pause it and get it down. All right. Vacation. All right, here we go. H of x equals 3x squared plus, did too much. Right there. Okay. H of x equals 3x squared plus 23x plus 40. So I know my A term is 3, my B term is 23, and my C term is 40. Plug it in. -b plus or minus the square root of b squared minus 4ac all over 2a, okay? I'm going to write it once right here for you. Plus or minus the square root of b squared minus 4ac all over 2a. So here we go. I'm going to start down below it, and I'm going to work my way up. X equals my -b, -23, plus or minus 23 squared. Ooh, don't like how that came out. 23 squared minus 4 times 3 times 40 all over 2 times 3. Now, I can do that radicand, right? Everything underneath the radical called a radicand, and I can do it all in one fell swoop. 23 squared minus 4 times 3, right? Yep, times 40, and that gives me 49. So this is x equals -23 plus or minus the square root of 49 all over 6. So now I'm going to take that and I'm going to go right up here with it. So x equals a negative 23 plus or minus 7 all over 6, because the square root of 49 is 7. So I'm looking for two answers, one to the positive 7 and one working with the negative 7. So x equals negative 23. Don't like how that came out either. Negative 23 plus 7 divided by 6. So x equals a negative, what is that, 16 divided by 6. So x is a negative 8 over 3, right? And it didn't want any decimals, so I'm going to leave it just like that. Okay, I'll leave it just like that. I'll leave it in a fraction because it doesn't want decimals. And our radical went away anyway because the square root of 49 is 7. And now I will do the one right next to it. And that is x equals a negative 23 minus 7 divided by 6. So this is a negative 30 divided by 6, or negative 5. And so my other root here, my other solution is negative 5. And there are my two. All right, C. Make sure you get all this down. Pause if you need. I'm going to start erasing to give myself some room. Okay? So I'll let you pause now if you need it, while I erase. Right? So here we go. The first thing I have to do here is I'm going to move that 7 to the other side. Okay? So I need negative 7, negative 7. So this becomes x squared minus 3x minus 7 equals 0. Right there. And so my A term, my A is 1, my B is negative 3, and my C is negative 7. And I always list them out. Negative B plus and minus the square root of B squared minus 4AC all over 2A. Okay? So x equals a negative 3 plus or minus the square root of b squared negative 3 squared minus 4 times my a times my c all over 2 times a. X equals 3, because negative negative make it positive. In parentheses, negative 3 squared. Ooh. So 3 squared minus, and that's a negative 3 squared minus. Make sure you put inside parentheses when you put in your calculator. Minus 4 times 1 times negative 7. That gives me 37. So the square root of 37 all over 2. Well, 37 can't be simplified, right? Because 37 is a prime number. So my solution here is simply where I am right now. And there you go. That is my solution. X equals 3 plus or minus square root of 37 over 2. The two solutions because of the plus and the minus. Okay? 3 plus square root of 37 divided by 2, and 3 minus the square root of 37 divided by 2. All right, turn the page. And then you are almost done. Look at that. We are down to the nitty gritty, the very end of it, the end of your sophomore year going to your junior year. And I said that we were going to talk about the discriminant here, and here we are. Ready? It says the discriminant, the value under the radical in the quadratic formula is referred to as the discriminant. So in this case, the radicand, anything underneath the radical, has a more specific name, and it's called the discriminant. And the discriminant is huge, okay? It tells you a lot of things, okay? The discriminant determines how many roots or zeros the quadratic function will have. You know how many solutions you're going to have and what type they are based on what's underneath the radical. That's gigantic, especially when it comes to the ACT, right? Because if they give you a quadratic, a quadratic, you could do just the discriminant and know if they're opening up or down or whatnot just by the b squared minus 4ac. Okay. Now here's the thing. If b squared minus 4ac, if b squared minus 4ac is greater than 0, which means a positive number above 0, right? It's a positive number. Then it's going to be positive, right? It's a positive number, right? So b squared minus 4ac equals a positive number, right? Then it's going to have two real roots, okay? Meaning not imaginary, okay? Which means there is no negative underneath the radical. What's underneath the radical is a positive number, okay? It's going to have two real roots. So basically, the graph is going to cross the x-axis twice, okay? Crosses x-axis twice. It has two positive real roots, okay? Or it has two real roots, not necessarily positive, right? Because it could be a negative root, right? It could be on the negative side of the x-axis. It's going to have two real roots. That's what I was trying to say instead of positive. Mind you, it's the notes for me as well, okay? Now, if my b squared minus 4ac is equal to 0, then we're going to have one root where it's considered a double root. We've seen this before, right? So basically, this is what it means, is that the graph sits on the x-axis. It's going to sit on it. So it would look, like this. Now, it doesn't have to be crossing the y-axis like I have it, but the bottom line is the graph is going to sit on the x-axis, okay? It doesn't matter which way it's shifted along the x-axis, but it's sitting right on it. It doesn't go down below it. It sits on it. That's when the b squared minus 4ac is equal to 0. So if you get the square root of 0, it's just 0, right? Okay. Now, if my b squared minus 4ac, the value underneath the radical, if that is less than 0, which means it's b squared minus 4ac is equal to a negative number, then I'm going to have no real roots, none. So the graph is above or below the x-axis. And I'm going to draw two of them here just so you see it. Like I could have one here, right? It's above it. Or I could do one like right here, right? The bottom line is it never crosses the x-axis, okay? And these are called non-real roots. They're technically imaginary roots. And if we got to imaginary numbers, this would make more sense to you. The bottom line is this, that when we're doing this, if you get a negative underneath the radical, then that is an imaginary solution, okay? Which means that the graph, when I graph it, would not reach the x-axis. It's either going to stay above it or it's going to stay below, but it's never going to reach it, okay? Now, the nice thing about this is that sometimes you just can look at graphs and figure out what kind they are, and all you got to do is the b squared minus 4ac. You don't put it underneath the radical. You're just trying to find what that actually is. So let's look at this. My a term here is 9. My b term is 12, and my c term is 4. So I want to know what b squared minus 4ac is. So 12 squared minus 4 times 9 times 4. And I can put it in the calculator just like that. 12 squared minus 4 times 9 times 4. And I get 0. So when I put that in my calculator, I get 0. So how many roots are this going to have? Well, it's going to have one real root, or just one root. And it's considered to be a double root, okay? So look at the next one. 4x squared minus 9. My A term is 4. My B term, well, 0. There is no linear term here. There is no B term, right? It's 4x squared minus 9. So really, this is really 4x squared, right, plus 0x minus 9, okay? There is no x term here. So my B is 0. My C is negative 9, okay? So don't let that fool you. That negative 9 is not my B term. It's not because it's second. Remember, linear term is second, right? It's ax squared plus bx plus c, right? So b squared minus 4ac. So 0 squared minus 4 times negative 9. So I can put that in the calculator. 0 squared minus 4 times negative 9. And I get a positive 144 when I do that. So this has 2 real roots. Whoop. Okay, 2 real roots. Last problem of the year goes right now. A is 2, B is 12, C is 20, B squared minus 4AC. So 12 squared minus 4 times 2 times 20. 12 squared minus 4 times 2 times 20 is a negative 16. So my answer to this is no real roots. And ladies and gentlemen, notes for the school year are complete. No more notes for you. Hopefully you're going to have a great summer. Hopefully we get out of lockdown here soon. When I'm filming this, we are in the midst of lockdown. Technically, it's still April when I'm filming this. So I'm trying to get some things done. I'm going to start painting the house, and I'm going to retile the main living area. I'm getting rid of carpet and going to a tile in our house. So I'm going to be working on some projects. Office hours, noon to 1 every day, Monday through Friday. Hey, remember this week, finish strong. Do the worksheets, do the Delta Math assignment and homework check, especially for those of you who are wanting to raise your grade, right? Wanting to raise your grade. I'm expecting 100% effort, 100% participation, and above average scores on your homework checks in order to raise your grade. There's no way to test you, so that's what I'm looking for. Have a great summer. Miss you guys. See you.